In the world of test and measurement, especially during automation, the scalability of your test systems can be key. And using traditional box instruments like the oscilloscopes that we have here, scalability typically comes in the form of adding a new instrument to your system and trying to figure out how to automate and getting all of those synchronized. Well, what we want to do and what we've done and what we're going to talk about today is breaking out of the box, where we can go ahead and take a system and instead of using scalability through adding more boxes to it, we're going to talk about using modular instrumentation and treating your system as a unified instrument regardless of the number of channels you got. So let's go. So in this session, we're going to be talking about two very specific things. One, we're going to be highlighting the usage of our latest and greatest 5108 8-channel, or there's a 4-channel version, oscilloscope. And then more importantly, we're going to be talking about the driver technology that we've enabled that allows you to create a system of almost 17 separate oscilloscopes, giving you many channels, all acting as one unified instrument. That technology is the synchronized multi-instrument sessions, where you can basically use one driver session and configure everything, which is pretty impressive. Now, the situation that we have here today, and we're kind of comparing, is if we've got 16 channels on our multi-segment LED display back there, we would need to have up to 2 separate 8-channel oscilloscopes set up to look at all of the signals. Now, it's not impossible to go ahead and do that. Indeed, you can, but it comes at a cost because when you're working with multiple instruments, you expect that there's going to be an alignment between everything. And although it's not impossible, you can see that even just the cabling diagram is very involved to get the 16 or to get scalability on boxes like that. And that's something that we know that matters a lot to you as a test engineer to make your lives that much more efficient. And so instead, we're going to go ahead and use this setup here where we have 2 8-channel oscilloscopes in our system, and then we're going to go ahead and hook up to those 16 lines coming off of it, and we're going to go ahead and automate that with the driver. So let's go ahead and see what that looks like live from Instrument Studio working with these instruments as a unified system. So with most modern instruments, there's a piece of software. It could be an operating system like Windows, and then a piece of scope software loads. The interactive experience for using NI PXI scopes is Instrument Studio, a free piece of software that gives you that out-of-the-box experience. And so if you had multiple scopes in your system and you really wanted to, once again, look at them as one unified instrument, you would go through and you could do, say, an auto-create layout. It'll scan your system, but we're going to do a little bit more manual layout here, where we're going to go ahead and pick up and we're going to go ahead and set into the system 2 oscilloscopes, 2 separate physical oscilloscopes. And you can see here that now we have slot 5 and slot 6 acting as one oscilloscope 1, giving us a 16-channel oscilloscope. Now, rather than go through and load that up and configure all of those 16 channels appropriately, we're also going to take advantage of a great feature of Instrument Studio, which is its project-based style interface, which gives you the ability to have a variety of pre-configured individual kind of panels that are either multiple instruments. It could be a mix of heterogeneous instruments. And we're going to go ahead and do that right now by loading up a combined view that's going to look at our panel, kind of the digital protocol going through it. So now that we have that panel already loaded and configured, each one of the channels, you can see that we've got the triggering set up on it. And you can see kind of at the top traces, it's the R, G, and B slices of our display that you can see over there, where we have a black bar tracing across each one of those. Kind of giving us, once again, the idea of like, well, it's just any oscilloscope, isn't it, Norm? Well, the idea is that, yes, it is, but don't forget we're using 2 separate physical 8-channel oscilloscopes now acting as one system, triggered off of a single signal, aligned in time and sample rate, reference clock, and more. So let's go ahead and look at what that would look like a little bit more if you were to dig into how aligned are those 2 signals. So using that same feature with an Instrument Studio, we're going to go ahead and load up a pre-configured panel that's going to basically zoom into 2 of those. And one of the things that's really nice, once again, is I didn't shut down the configuration of the other one. It's gracefully transitioning from one configuration to the next. And so what we have here, let me go ahead and actually make it a little bit more apparent. We're looking at 2 separate traces from the 2 separate physical instruments. And I can kind of see that if I come down here in the bottom right-hand corner a little bit, zoom in, you'll see that we have 2 different channels configured right here, one for the output enabled 1 and the other for output enabled 2. So if you're using an oscilloscope, you expect that all of your channels are aligned. And keep in mind, once again, if your idea of expansion is just add another box on top of the box or inside of a rack, you've got to take all the effort to make sure that those are perfectly aligned in time and samples to do the work that you would expect to do with a time-aligned multi-channel instrument. So let's go ahead and I'm going to go ahead and pause this real quick and just do a single acquisition. And we're going to go ahead and zoom right in on those two signals. And we can see that they are right on top of each other. There's nothing that I can do to really make that any more apparent, except one of the great features that we have within using modular instruments is the rapid nature and the ease of which you can program your NI PXI modular instrumentation. So let's go ahead and look what that, let's look at an example of what that code would look like very briefly, and then we're going to show it live as well. So the illustration that we have on the screen here, even if you're not a LabVIEW programmer, you can get the basic idea of what we're doing. You can see that we're going through and we're configuring and we're connecting to one of the oscilloscopes. We're going through and configuring the vertical range, kind of the timing and the sample rate, and then we're going through and fetching from one of the oscilloscopes. Now, the example that we're staring at here is what it would look like in kind of any situation. This could just be boxes as well, as to how you would go through, configure in parallel, and fetch in parallel all of the information from multiple separate oscilloscopes. There's nothing unique about this except that LabVIEW is allowing you to do it in parallel. Keep in mind, if you were trying to do this with multiple oscilloscopes, you'd either need to, with a kind of a sequential or traditional programming language, you'd have to do all of this sequentially or do all of your parallel threading just to be able to do all of this in parallel. But this isn't a program, this isn't a session talking about LabVIEW, but if we were doing it a little bit cleaner in LabVIEW, we would also be able to take advantage of features like the parallel for loop, where the program gets even easier and simpler. But keep in mind, this is still working with, this is not working with, but this is still programming it as though it's for separate instruments. But that's not what the synchronized multi-instrument sessions are about. It's the idea that, hey, we're going to take all of this complexity, even in its simplicity in LabVIEW, and we're going to turn it into this, where up front, you would identify all of the instruments, you would identify the channels on the instruments that are relevant, and then regardless of language, you now have the ability to do the fetch of all of those instruments, all of those channels, all at once, regardless of your programming environment. Now, this is a driver level feature, and once again, we're showing it in LabVIEW, but whether or not you've got .NET, C, or C++, or I believe even Python, you should be able to do this exact same capability because now we've enabled it into the driver. Once again, giving you a unified experience. Now, what we're going to do here is we're going to go ahead and look at the actually running live and see what this looks like for not the 4 instruments that we have in these slides, but rather just the 2 separate oscilloscope cards, once again, looking at those 2 separate aligned channels. So what we're going to start off with here is comparing what it looks like when you don't take any effort to get those 2 instruments aligned, except using the exact same signal that's incoming. We kind of branched out to one signal to both scopes to trigger off of. And let's see what that looks like. So what we have here is we're actually taking advantage of another great feature of Instrument Studio and our driver, where we can use Instrument Studio to interactively configure things exactly like what we want, actually using the same configuration we just saw a moment ago, and then use that to actually load into the driver dynamically at runtime. It goes faster than sending any skippy commands across. Super great feature for automation. And then we're going to go through and we're going to fetch both of those different signals. You can see we're doing a scope fetch right there. And then we're going to do some basic statistics to look at the distribution of the alignment of those 2 signals. So nothing too glorious, but when we go ahead and turn this on, we're going to go ahead and we can already see that there's some variation in terms of both signals. But let's go ahead and zoom in a little bit down here. Take an individual snapshot. And although it looks like we're pretty well aligned on the individual signal, the closer that we get in, you can see that there is a separation between each one of those samples. And in fact, as we were to go and, let's go ahead and get right there, and we're going to let it run for a little bit more, you can see that that difference in where the samples are actually being sampled at has a reasonable amount of variation. And in the distribution, the kind of the statistical histogram in the bottom, you can see that we're going kind of almost plus minus 5 nanoseconds. If you were sampling at like a gigasample a second, that's 10 samples apart. And so let's go ahead and pause this real quick and we can see that variation of each one of those samples. And if you kind of look at those dots that you might be able to see up there, every time I grab a new sample, the difference in the alignment of those 2 oscilloscopes varies wildly. Well, not wildly, it's within a couple 10 nanoseconds. But at the same time, if you're working with an oscilloscope Do you expect all of your channels on your oscilloscope to vary by nanoseconds? Probably not. You expect them to be pretty well aligned on top of each other. Now, if we change this around a little bit and we turn on a multi-instrument session, what we can now see is that there is basically zero distribution of the points in the system. If we really wanted to get in on that one, let's go ahead and turn off kind of pause it for a brief moment here, and we can really get in on that signal, and we can look at what each one of those points are at. And you can see that we're really, there's zero separation of the individual signals here. Let's go and let that run, and they land right up on top of each other. And this is exactly what you would want if you're taking a channel or if you're trying to add multiple instruments to a system. You want the starting point, the trigger to be aligned. You want the samples to be aligned because you've got the job to do. You've got some engineering work where either you need to get the data into software to continue to do the job, or you need to work with it interactively and you want to have a single trigger orchestrate all of the parts and pieces of all the things that we've got. Now, taking a step back from looking at it in code, what would it look like with the physical hardware setup that we've got? So what we know is that within the system that we have here, we've got our two 5108 modules, each supplying 8 channels, and you saw it working, all of them acting as a single oscilloscope. And really, if we needed to go to a 24 scope or 24 channel scope, or even if we needed to go all the way up to say 32 channels of oscilloscope, make sure I get it in there right? These are not hot swappable, so I'm not gonna push them in, but that's basically it. Shut down the system, plug in the slots, turn it back on, and take the exact same steps that you saw just a moment ago. So with the system that we've got here, let's do a quick recap of all that we've covered. So in the name of automation, in the name of scalability, PXI instrumentation really gives you the most amount of capabilities. It gives you the ability to automate very cleanly and quickly, as we saw, in turning 16 or more instrument calls down to just a single line or just a few instrument calls in whatever language of choice. We've given you the ability to scale across a chassis. Now, in here, we had a simple illustration of looking at, say, 4 separate ones, but it's possible to load an entire 18-slot chassis with these modules, giving you the ability to have upwards of 136 different oscilloscope channels for some of the most demanding tasks that are out there, or not only necessarily the demanding of tasks, but also just the number of devices you might want to test in parallel. Now, all of these different situations, whether it's 136 channels or just 16 like what we've got here, we're focusing on giving you the ability to automate interactively through Instrument Studio and making that a pretty seamless getting started experience so that you can get to your measurements or get to your signals, and then also the ability to get the access to those instruments and automate them reliably and fast. Now, lastly, speaking of fast, one of the big differences, especially when you're working with something at scale like this, is access to the data. Now, if you think about, hey, I've got a 4-channel oscilloscope and I want to get one record off of it, it might not take that much if you're using something like USB or even gigabit Ethernet. You might not have thought about it. But the minute that you start to really go beyond 2 and 4 or going to 16 or Lord only knows to 136 channels or 136 channels, the data throughput, it could take a very, very long time, up to 4 seconds just to transfer the traces to the computer to continue to do whatever experimentation, characterization, validation, even production test. And so one of those differentiating features of modular instruments within PXI is the access to massive amounts of data, be it for streaming or just getting one record of many, many channels. You've got the ability to go from what traditional instruments might take 4 seconds, 2 to 4 seconds to transfer, 4 to 8 channels worth of a 10 millisecond acquisition, down to hundreds of milliseconds or less depending on your configuration within a PXI system. It's still a lot of data, but you're orders of magnitude different on the overall time to transfer, to process, and to get all that data. And that's really what we're bringing to you today. We've got our latest and greatest 5108 to give you density of channels at a competitive price point. We've got multi-instrument sessions within the driver, giving you the ability to do parallel operation on multiple instruments, getting them all aligned with basically no extra coding needed, and then the ability to process all of that information very simply using LabVIEW or your programming language of choice. Whatever those situations are, we hope that the ability to scale, the ability to stream, and the ability to process your data gives you the ability to differentiate and get the job done faster and to do more with NI. Thanks.